Look up at the night sky. You see countless stars, each a sun, perhaps with its own worlds. Humans, on our small blue planet, have often looked to the heavens for inspiration. Yet sometimes, we create wonders right here on Earth. These wonders rival the grandeur of nature itself. The Hoover Dam is one such marvel. It stands as a testament, a colossal monument. It speaks to what we can achieve when ambition meets ingenuity. It is more than just concrete and steel. It is a story of human endeavor, a symbol of our power to reshape our world. Imagine the forces involved, the immense pressure of a vast lake, the unyielding strength of rock, the relentless flow of a mighty river. To tame such elements requires a deep understanding of physics. It demands courage. It necessitates a vision that spans generations. The Hoover Dam embodies all these things. It is a structure born from the audacious dream of controlling one of North America's most formidable rivers, the Colorado. This wasn't just about building something big. It was about harnessing primal forces for human benefit on a scale never before attempted. Consider its sheer size. It is a concrete arch-gravity dam. This means its curved shape directs the water's force into the canyon walls. The canyon walls themselves become part of the dam's strength. The early 20th century saw explosive growth in the American Southwest. Cities like Los Angeles were burgeoning. Agriculture was expanding. But this region is, by its very nature, arid. It is a desert landscape, beautiful yet unforgiving in its scarcity of water. The Colorado River was both a lifeline and a menace. Its waters were essential for life and progress. Yet its unpredictable floods could wreak havoc. This paradox set the stage for a monumental undertaking. Finding the right location for a dam of such unprecedented scale was critical. It wasn't just about stopping a river. It was about finding a place where the earth itself could lend its strength to the human endeavor. Engineers scoured the course of the lower Colorado River. They sought a site with specific geological characteristics. The canyon walls needed to be strong, composed of solid rock capable of withstanding the immense pressure the dam and the reservoir behind it would exert. The canyon also needed to be relatively narrow to minimize the span of the dam, making construction more feasible and cost-effective. After extensive surveys and geological investigations, Black Canyon emerged as the prime candidate. Located on the border between Arizona and Nevada, it offered a unique combination of advantages. The canyon walls here were composed of dense volcanic rock andesite breccia. This ancient rock, forged in the Earth's fiery past, possessed the immense compressive strength required. The canyon was also deep and relatively narrow, a natural choke point for the mighty Colorado. It was as if nature itself had sculpted the perfect foundation for this monumental human undertaking. The decision was made. The construction of the Hoover Dam was not the work of a single genius. It was a grand collaboration. It involved a vast orchestra of talent, from brilliant engineers to tireless construction workers, guided by the hand of government officials. The vision was ambitious, almost audacious for its time. To build the world's largest dam in one of the most inhospitable places on Earth required an unprecedented level of coordination and shared purpose. It was a project that captured the imagination of a nation struggling through the Great Depression, a symbol of hope and human capability. The engineers were the architects of this dream. Men like Frank Crowe, the chief construction superintendent, brought innovative ideas and relentless drive. They pored over blueprints, calculated stresses and strains, and devised new methods to tackle problems never before encountered. They had to invent solutions on the fly. How do you pour that much concrete without it cracking from the heat of its own curing? How do you divert a powerful river while you build in its bed? These were questions that demanded groundbreaking answers, pushing the boundaries of engineering science. Then there were the thousands of workers. Section 5. Trials by Fire and Stone. The Human Cost of Ambition. The construction of the Hoover Dam was an epic struggle against nature and the limits of human endurance. The conditions faced by the workers were incredibly harsh. Black Canyon in the 1930s was a desolate, searing cauldron. Summer temperatures regularly exceeded 120 degrees Fahrenheit or 49 degrees Celsius in the shade, and deep within the canyon, where men toiled, it was even hotter. There was little respite from the oppressive heat. Dust filled the air, a constant irritant to lungs and eyes. This was not a place for the faint of heart. It demanded extraordinary fortitude. The work itself was fraught with danger. This was an era before modern safety regulations were commonplace. Workers, known as high scalers, dangled precariously on ropes hundreds of feet above the canyon floor. Their job was to clear loose rock from the canyon walls, a task that involved dynamite and jackhammers, with the constant threat of falling rock or equipment. Tunnels were blasted through solid rock, filled with choking fumes and the risk of cave-ins. The sheer scale of the machinery and materials being moved created countless opportunities for accidents. Section 6. Rivers of concrete, mountains of steel engineering the unprecedented. Building the Hoover Dam required more than just brute force. It demanded groundbreaking technological innovations. The sheer scale of the project pushed engineering practices to new limits. One of the most significant challenges was the concrete. A dam this massive, if poured in one continuous block, would have taken over a century to cool and cure. The chemical reactions involved in concrete setting generate enormous heat. This heat would have caused catastrophic stresses and cracking. The engineers needed a revolutionary approach to concrete placement. Their solution was ingenious. Instead of one monolithic pour, the dam was built in a series of interlocking trapezoidal columns. Imagine a giant three-dimensional jigsaw puzzle. Each block was poured individually. To manage the heat, an elaborate cooling system was embedded within the concrete. Over 582 miles of 1-inch steel pipes circulated refrigerated water through the setting concrete, dissipating the heat and allowing it to cure properly and strongly. Section 7. Powering a nation, shaping a landscape. The dam's transformative touch. The completion of the Hoover Dam in 1936 marked a pivotal moment for the American Southwest. Its impact was immediate, profound, and far-reaching. One of its primary purposes was to generate hydroelectric power, and it did so on an enormous scale. The massive turbines, spun by the controlled release of water from Lake Mead, began to produce vast quantities of electricity. This power illuminated cities, fueled industries, and transformed daily life for millions of people. Los Angeles, Las Vegas, and numerous other communities suddenly had access to a reliable and relatively inexpensive source of energy. Beyond electricity, the dam brought jobs and economic stimulus during the depths of the Great Depression. The construction itself employed thousands, but the long-term effects were even more significant. The availability of water and power spurred agricultural development. Section 8. Echoes in the Canyon. A legacy carved in water and power. The Hoover Dam's influence extends far beyond its immediate physical presence. Its legacy is deeply etched into water management and power generation worldwide. The successful taming of the Colorado River provided a blueprint for other large-scale water projects. Engineers studied its design, construction methods, and operational strategies. Innovations like concrete cooling and diversion tunnels became standard practices. It set a new benchmark for what was possible. In power generation, the dam was a pioneer. It demonstrated the potential of hydroelectricity as a clean energy source. Its efficient operation provided a model for future hydroelectric facilities. Generating and transmitting electricity over long distances was a game-changer. This legacy continues today, as hydroelectric power remains vital for its reliability and low emissions. However, the legacy of large dams includes environmental considerations. The alteration of a river's flow and impact on ecosystems are now significant areas of study. Section 9. The Dam Today. A living legend, ever evolving. Decades after its completion, the Hoover Dam remains an iconic American landmark and a vital piece of infrastructure. It draws millions of visitors each year from all over the globe. They come to marvel at its sheer scale, its elegant design, and the dramatic beauty of its setting in Black Canyon. You can walk across its crest, feel the vibrations of the immense power it contains, and descend deep into its heart to see the massive generators at work. Modern drone footage often captures breathtaking aerial perspectives, showcasing its graceful curve against the stark canyon walls, views impossible for its builders to have imagined. The dam is not a static monument. It is a working machine that requires constant monitoring and maintenance. An army of engineers and technicians works tirelessly to ensure its continued safe and efficient operation. They inspect the concrete for any signs of stress or degradation. They maintain the intricate network of turbines, generators, and spillways. The structure is instrumented with sensors that provide real-time data on its structural health and performance. This ongoing vigilance is crucial to preserving this engineering marvel for future generations, ensuring it can continue its vital functions. As technology advances, so too does the management of the Hoover Dam. New analytical tools, predictive maintenance techniques, and upgraded control systems are incorporated to enhance its efficiency and longevity.